Hello. The lesson I want to do today involves bringing some of the real number properties into the geometry class to be able to help enhance our ability to do proofs. And the first topic that I want to talk about is reflexivity. This topic looks kind of useless in your Algebra 1 setting, but it becomes much more powerful in the geometry setting. I want to highlight this property so we understand its usefulness. All right, in algebra, reflexive property tells us x equals x. So basically, given a real number, say 5, it's going to be equal to 5. This is why I say it doesn't look useful from an algebra setting. But when we bring in geometry, it becomes much more useful. Looking at this diagram, there's something that we can say about this diagram based on what we're given and the reflexive property that we may not otherwise have if we didn't understand the use of the reflexive property. I want to get an idea of equality out of this triangle. And what I'm going to do is I'm going to look at the big triangle and breaking it in half here. So it creates two smaller triangles. And these two smaller triangles will be labeled according to these labels. So we have this vertex is A, this vertex is D, this vertex is D, this vertex is C, this vertex is B, and this vertex is B. So what we see is that this triangle and this triangle are the separation of this triangle into its smaller parts. And we can say something about the equality of this triangle with this triangle because this side and this side are the same length because they were originally the same side. So we have that segment DB is congruent to DB. Over here, the way we get these congruent sides is we took segment DB and we split it into two pieces. But by the reflexive property, we could have stated that to begin with from this triangle. So in argument form, we could have said that DB is equal to DB by the reflexive property. That's why this becomes important to be able to use the reflexive property, because in an argument situation, if we wanted to argue from the original diagram that this side shares some property with this side, we can immediately start with this. The next real number property that I want to talk about is transitivity. We can also bring this into geometry to make it a useful property to us. And I have an example with a measure of angles for us to look at. I have the measure of angle ABC is less than the measure of angle DEF. And I also have the measure of DEF is less than the measure of angle HIJ. From this, using the transitive property, we can conclude a statement about the relationship of angle ABC and angle HIJ. We can state through transitivity that the measure of angle ABC is less than the measure of HIJ. So we get this from the transitive property. This allows us to relate two possibly unrelated angles, or what appears to be unrelated angles, to each other through the transitive property. The next property of the real numbers that I want to use is substitution. Substitution is what allowed us in algebra to be given an equation and a value and then plug that value into the equation to do some problem solving. Again, we can make use of this in the geometry class by having something like this. Angle A plus angle B plus angle C equals 180 degrees. And then we can be told that angle B is 40 degrees. So we can substitute that in here and use that in a problem-solving scenario. All right, I want to walk through using the algebraic properties in a proof setting so that we can see something that we had in algebra and the new ideas that we're learning and developing two-column proofs in geometry and kind of combining those ideas together. So this is going to look a little bit like what we did in algebra, a little bit like we've been doing in two-column proofs and bringing those together. So I'm going to start with the theorem that if 8x divided by 3 equals 16, then x equals 6. And we want to do this as a two-column proof. So I'm going to put my divider in here, and I'm going to start with my given, that 8x divided by 3 equals 16, and the reason is it's given. And so now I'm going to go through this and do my typical algebra problem solving skills, but on this side I'm giving the reasons from the real number properties and why I can make and do the things that I do on this side. So the first thing I want to do is eliminate the fraction. So I'm going to multiply both sides by 3. I can do that because of the multiplication property. And when I multiply 3 times the fraction, I am going to get 8x over 1. And then I want to do the 8x divided by 1. I'm allowed to do that because of the division property. Now I want to divide both sides by 8. Again, I'm going to use the division property. And so I have x equals 6 here. That is what I was trying to prove. So I am done with my proof at this point. And you can put your favorite proof mark in there. And so now we've used real number properties in a two-column proof to do some kind of algebraic theorem to kind of bring these two classes together. Cheerful calculations.